VLSos here. This is a pre-algebra video lesson, multiple event probability. I have an example problem here to consider. What is the probability of flipping a head and rolling a 1? And we mean flipping a head on a coin and rolling a 1 on a 6-faced die. But not the probability of getting either one of those. What is the probability of doing both those things at the same time? It's a more difficult probability calculation. So this is an example of a probability calculation that has multiple events. The flipping of a coin and the rolling of the die are called experiments. It's an activity that we take, and the event is the outcome that we observe when we do the experiment. So we calculate the probability of events, and we use notation P for probability. And inside the parentheses, as we've learned in a previous lesson, we're interested in the probability of an outcome. But we call probability of outcome 1 because there could be another event and another probability of calculation with a different outcome, different experiment, different outcome. So these two, this notation is for two separate events, event 1 and event 2. In our example, we have the flipping of a coin, which is one separate event, and the second thing that we're doing is the rolling of a die. We know how to calculate single events, but what do we do when there's multiple events? We simply multiply. I point to this and highlight that the math that we're going to do is multiply. So to answer this question, we need to first find the probability of each event separately, and then we'll multiply. So what's the probability of flipping a head? Well, we might know this straight off, but the way to organize our answer is to think of the probability as a fraction, put the number of ways that we can get ahead by flipping a coin, and there's only one way to do that. And in the denominator, put the total number of possible outcomes on a coin, and there's only 2 ways to flip a coin, so we put a 2 in the denominator. So much for the flipping of a coin. Let's think about the die. We're going to express it as a probability, as a fraction. There is only one way to roll a 1 on a 6-faced die. So 1 belongs in the numerator, and in the denominator we have 6 possible outcomes in rolling a common die. So what is the probability of flipping a head and rolling a 1? Well, I'm going to multiply these 2 separate events. This is a 1/2 times a 1/6. Fraction multiplication, we multiply the numerators and get 1, we multiply the denominators to get 12, and we have our answer. 1 out of 12 times, if I flip a coin and roll a die, I will get a heads and a 1. Got a heads on this experiment, but I rolled a 5, so I did not get a 1 and a heads. Let's do one more example. What is the probability of getting blackjack? In the card game called blackjack. So we won't review the game in its entirety, but getting blackjack from a common deck of cards means getting 2 cards, one of which is a face card, and the second of which is an ace. So what is the probability of getting a face card and an ace at the same time if you draw 2 cards from the 52 cards? Well, we know that we're going to have 2 events, so we're going to calculate the separate probabilities of getting a face card and the probability of getting an ace, and then multiply them. The probability of getting a face card, there are, or we could get a 10 as well. There are 3 face cards in each suit, Jack, Queen, King, and there's a 10. So we're going to get a score of 21 in blackjack by getting one of those 10s, and there are 16 of them in the deck out of a total of 52 cards. And I'm going to multiply now by the chance of getting an ace, but I have to be careful. This is a pretty sophisticated calculation. There are 4 aces in the deck. But if you know that you have already drawn a card that needs to be one of the cards that is worth 10, or a face card, then there are only 51 cards left to get an ace from. So to calculate the probability of drawing something that's worth 10 and then drawing something that's an ace that's worth 11 in the game to get a total score, the highest score of 21, which will guarantee you a win, I believe, we multiply 16 over 52 and 4 over 51. When we do, that'll be 64 out of 2,600. I've done the calculation previously. But we have to be careful again in considering this game. We could have gotten an ace first and then drawn the 10 that we need in order to get a blackjack or a score of 21. So I have to include that calculation and consider that I could have drawn an ace and then the card that's worth 10. So if I'm going to correctly calculate the odds of this game, I need to multiply this by 2 in order to account for the 2 ways in which we can get our cards. And this is very approximately 5% likely. Let's see if I get a blackjack if I draw 2 cards. I already didn't get one card that I needed, and the second card wasn't good either. I did not get a blackjack.